Alright guys, never have I ever quarantine edition. Put up 5 fingers. I'm gonna say a couple sentences, and if you don't want some of those things, you have to put a finger down. Let's start. Never have I ever watched Tiger King. Never have I ever downloaded TikTok and spent more than 30 minutes on it. Never have I ever said, okay, it's time to do some schoolwork, and only did about 5 minutes of actual schoolwork. Never have I ever skipped an online class. Never have I ever started a sentence with, once the quarantine is over, I'm going to. Alright guys, that's it for the game. Tell me in the comments how many fingers you put down, and if you say you didn't put any fingers down, I know you're lying. Hello guys, welcome to chapter 32, where all we talk about is electromagnetic waves. Today's problem is 32.7, and without further ado, let's get started. First thing I'm gonna do is calculate the frequency of my wave. So I'm gonna take my velocity of light, so 3 times 10 to the 8, and divided by my wavelength, which is 4.32 times 10 to the negative 9, and I have it that my answer is 6.94 times 10 to the 14 hertz. Now it's time to calculate my Emax, which is basically my Bmax times C, which is the speed of light. So once I do, it's going to be here. 1.25 times 10 to the negative 6 times 3 times 10 to the 8, and I have that it is equal to 375 volts per meter. Now my next step is to calculate my wave number, for which I'm going to use the formula K equals 2 pi over wavelength. So I have 2 pi over 4.32 times 10 to the negative 9, and my answer is going to be equal to 1.45 times 10 to the 7 rad per meter, radians per meter. Next step is to calculate my angular frequency, so I can start plugging in stuff into my formulas. So I have it that my angular frequency is equal to the speed of light, 3 times 10 to the 8, times my K, which I just calculated here, which was going to be 1.45 times 10 to the 7, and my answer is going to be 4.36 times 10 to the 15 rad per second. And now I'm ready to start plugging in stuff into my formulas. So now it's time to finally answer the third part of the question. I have it that E of x t is equal to J vector Emax, which is here 375 volts per meter, and then cosine of Kx, I have my K over here, my K is going to be 1.45 times 10 to the 7 rad per meter, going to be x minus, now Wt, my W is right here, 4.36 times 10 to the 15 rad per second, and then T, and that's it. That's the formula for my E. And now the formula for my B is going to be very similar. B of x t equals my Bmax, which I already have, so it's going to be K vector 1.25 times 10 to the negative 6 Tesla cosine of the same numbers here, 1.45 times 10 to the 7 rad per meter, x minus 4.36 times 10 to the 15 farad per second t, which is my time, and then close parentheses, and that's the answer. Alright guys, thank you for tuning in. See you in the next problem.